We will do analysis of height versus nodes. This type of analysis we have already done on binary trees. So I will not do much explanation here. Directly I will try to write down the formula. We have to get the formula for height versus nodes of strict M-array trees, right? But as an example, I have taken a strict 3-array tree. So from these example trees, we will get the formula for M-array tree. Let us look at this. See, height of a tree is given as 2, and these are minimum number of nodes it can have. These are maximum nodes it can have. And the height is here 3. So these are the minimum nodes it can have. These are the maximum nodes it can have, right? These are also nodes, okay? So I need the formula. If height is given, minimum how many nodes, maximum how many nodes. So let us write the formula. Let us observe and write the formula. See, height is 2 means how many nodes are there? 3 plus 3 plus 1. So 3 plus 3 plus 1. It's nothing but 2 into 3 plus 1, right? Number of nodes. Then here when it is minimum, 3 plus 3 plus 3. So this is 3 into 3 plus 1. Number of nodes are there. So it means if height is given, then minimum nodes. How many minimum nodes are there? See, this 3 is a degree and 2 is height. 3 is a degree and 3 is height here. So 3 into h plus 1. So whatever the height is into 3 plus 1. But actually this 3 is degree of a tree. So I should call it as m. So I will rewrite the formula. This is m into h plus 1. Yes, this is the formula. So in a strict M-array tree, minimum number of nodes will be n equal to mh plus 1. Then the maximum nodes how many? Let us observe. 1, then 3, then 9. What about this? 1, then 3, then 9, then 27. If I write them, this is 1 and this is 3 and this is 3 square. This is 3 cube. So this is 1 plus 3 square plus 3 cube. So these are the terms of GP series. Yes. But what is this 3? 3 is degree m. So I will rewrite it like this. 1 plus m square plus m cube plus goes on up to whatever the height is. So this GP series, if I add, then if you remember the formula for GP series, I'll write on the formula. A r power k plus 1 minus 1 by r minus 1. This is the formula. So for this series, what is the formula? A is what here? A is 1. Okay, don't write it. Then r, common ratio is what? M. Power, k is what? H plus 1 minus 1. So m power h plus 1 minus 1 divided by m minus 1. This is m minus 1. Yes, this is the formula. See, once again I'll tell you, maximum how many nodes possible in a strict 3-array tree. The total number of nodes are forming a GP series formula. This is for degree 3. I convert it into degree m. Then this is the formula for some of the terms of GP series. This is the GP series. Then using the formula, I have added this one. I got a formula for this one. So m power h plus 1 minus 1 by m minus 1. So the maximum nodes are n equal to m power h plus 1 minus 1 by m minus 1. So that's all, we got the formulas. If you already know the height, then the minimum how many nodes, maximum how many nodes. Now the other formula we have to write on. If we know the number of nodes, then minimum height and maximum height. This was minimum nodes, maximum nodes. So I will write on for height. So if n nodes are given, then what is minimum height and maximum height? These formulas I can get them from here. Like the minimum nodes can give me maximum height formula. See, here it is n equal to mh plus 1. What is h? That one if you send here, n minus 1. Then m comes in denominator. So this h is equals to n minus 1 by m. Yes, n minus 1 by m. Then what about this maximum nodes formula gives minimum height? So this is having power So definitely this will be in terms of log. So you can convert this one, do paperwork and convert this. I will directly write on the formula there. See, this is the formula, log base m, n into m minus 1 plus 1, then entire result minus 1. So if you convert this, you get that formula. So these formulas are more helpful when you want to know maximum how many nodes are possible and what is the minimum height possible. So minimum height, you can see that it is logarithmic and maximum height is in terms of n. So this is logarithmic and this is linear. The purpose of all these analysis is to know the space and the time taken by trees when we really use them. When we use the trees, that time we will use these formulas also, right? That time I will not discuss. I will be discussing how to use them rather than discussing the formulas. So we are first analyzing and keeping the formulas ready, then we will use them afterwards. Next, one more formula is remaining, that is number of internal nodes versus external nodes. So I'll take the same example trees, I will remove this and let us find out number of internal nodes and external nodes. So from these example trees, let us find out internal nodes and external nodes for a strict 3-array tree. Then we will prepare the formula for any m-array tree. Let us observe. How many internal nodes are there? 1, 2. Internal nodes are 2. External nodes 1, 2, 3, 4, 5. Internal nodes 1, 2, 3, 4. 4. External nodes 1, 2, 3, 4, 5, 6, 7, 8, 9. Internal nodes 1, 2, 3. External nodes 3, 4, 5, 6, 7. Then internal nodes here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. External nodes, these are 3 power 3, that is 27. So can you find any pattern or the relationship between the values? Let me check. 2 and 5. 2 into 2 plus 1. Okay, 2 into 2 plus 1 gives me 5. Then 4 into 2 plus 1. So I will write 2 into 4 plus 1. Yes, that is 9. Then what about this? 2, 3, 6 plus 1, 7. Yes, 2 into 3 plus 1 gives 7. What is this? 2 into 13, 26 plus 1. Yes, 2 into 13, that is 26 plus 1 gives 27. So it means external nodes are equal to 2 into number of internal nodes plus 1 for a strict 3-array tree. Then for strict m-array tree, E is equals to, see this was 3, so I got a 2. So for m, it will be m minus 1 into I plus 1. Yes, this formula is for internal nodes versus external nodes. This is for any strict n-array tree.